For those of you who may have seen this model, this is a model that previous year students have made. It is a model, it is not necessarily to scale, but it's trying to show you some principle as to how we put the parts together to form a timber frame building. I'm not saying there's not errors to it, I'm just saying that this is just an indication of what you should be expecting. Now, you should know this by now. These things here are rafters. Fantastic. These ones are your ridge board or your ridge beam. Coming down the corner here, if you might remember, the photos are of a hip roof. Okay, so this is a hip roof. Let's see whether I can find a slightly better photo. There it is, a hip roof. This is a hip rafter. So these ones are your common rafters. This one here is your hip rafter. What is supporting the hip rafter? Your top plate. From your top plate down to your stud to your bottom plate, that's where your wall framing is. From top plate to bottom plate, anything between, that's your wall framing. Timber component, that is. Once you get past the wall framing, then you will have your floor, whether it is a platform floor or your strip flooring. Then you've got your floor joist. That's here, this little bit here, which goes the whole length of the building, which is supported by bearers. Bearers are supported by stumps. Between the bearers and the stumps are end caps. So the stumps, bearers, floor joists, and the flooring will form part of the floor framing components. The last component we're going to be doing is the bracing component. See those blue straps? Those blue straps are indicative of metal straps that we will be using for bracing. I'll be essentially teaching you two forms of bracing, the metal straps and hardboard sheeting. But we'll get to that later. So by now you should be very much familiar with the roofing component. Now we're going to spend 2 weeks doing the wall framing, top plate, bottom plate, and things in between. Another 2 weeks on floor framing, which is your floor joist, bearers, and stumps. So let's spend another 2 weeks on that, and then the final 2 weeks will be on type of bracing to make sure the building doesn't fall over or deformed. Okay, so components of a wall framing. Wall framing starts from the top plate and ends to this bit here, the bottom plate. What I'm going to do is to use this timber frame model. I also have photos of a single-story timber frame house and a 2-story timber frame house. I'm going to go through them, give you an idea as to how things work, to put things into more of a practical look. Okay, let's begin. So we've got the rafters passing on the load to a wall stud, going down to the bottom plate, passing onto floor joists, onto bearers, and onto stumps. The whole point of it, if you remember correct from our previous chats, is that the load of the roof and everything else is passed down in as much of a vertical manner as you can all the way towards the ground. Right, so we've got the parts. Top plate. Top plate always goes around the whole building on all the walls. Bottom plate here is similar, but you do not have your bottom plate where the door is. Okay, you trip over it, so you don't do that. See how it's in a vertical manner? So I've talked about that. The joining of walls, There are different ways of joining of walls. I've also mentioned that before. Remember the number 2 and 4? Those are two most common way of joining corners and etc. Wall starts, transfer the load from the top plate to the bottom plate, and wall start is just a piece of timber. How do you stop it from bowing? That's where the lintels come in. Think about it as a piece of long timber. You're applying pressure from the top and bottom. Think of it, say, a pair of chopsticks. You apply enough pressure, you bend it, and it will snap. Okay, that's what the knobbing is there for, to stop it from bowing and give it that bit more rigidity and strength there. Now, what else happens on the wall? You have to have a way to get into the building. Yeah, so you have doors and to look out from a window. So we call these wall openings. The whole point of, again going back to loads, how do you spread the load from going from the roof and crushing the door or the window? The way to do that is using a lintel. Okay, a lintel is like a massive piece of timber. You spread the load. The piece of timber that's I'm going to magnify this, by the way, just so that we can see that a little bit better. The lintel here. How to support the lintel really well? Using a secondary jam stud right underneath the lintel. There's always a pair as one and the other. This is called a secondary lintel. Secondary jam stud. Next to the secondary jam stud, there's the jam stud. Okay, and again, they come in a pair. This is a jack stud. We call jack anything when it is a shorter piece of what they're supposed to be doing. So this jack stud is essentially a smaller piece of a wall stud. Okay, so we call that a jack stud. And then we've got this bit. This bit is called a ledger. Okay, so where do we find the ledger bit? It's here. The ledger. It's right down the bottom, and or it can be called a lintel trimmer. So what is what? Go back up to terminology and definition, scroll down. This arrow is what we're looking at. It's called ledger. In the past, it's also called a head trimmer, so you can use the terms interchangeably. As with a window, don't know whether you can pick it out, but here's the window. It is similar. You still have to spread the load of the roof using a lintel onto your jam stud going down. Your secondary jam stud right underneath the lintel, and next to it is your jam stud. Come in pairs. That's your window sill trimmer, and that's your jack stud happening again. That's your window sill trimmer right there. Okay, look up a bit. Window sill trimmer, clause 6.3.6.6. 4 opening widths up to 1500. The trimmers can be of the same size and grade as the common studs in that wall. If it is more than that, then you look at table 6.3. 6.3, here it is. It covers N1, N2, N3, N, and 4. Assuming that we're sticking with MGP 10, as you can see, 90 by 35 can be used for opening width up to, keep going, down, 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 up to 2700 opening width. Okay. Thereafter, the sizes increase. Read the table and have a look. You should be aware that your 2/90 by 35, for example, is just two pieces of timber, dimension of 90 by 35, and two of them laminated together. Okay. Now let's have a look at a single story timber frame building. The picture you're looking at now is a transportable building. You can see that by the concrete stumps. I'm going to just talk to you about it, about the different parts to help you understand what we're looking at. So if I look at from the stumps onwards, that's your stumps, concrete blocks. Right underneath that, you've got bearer going horizontally. On top of that, you've got floor joist. Okay, I'm going to zoom in so to give you a better idea as to what we're looking at. So you've got your floor joist there. Okay, above the floor joist, you have 4 studs trenched into bottom plate. Zooming that in a little bit more. Okay, so this is your bottom plate. In this case, the bottom plate has been trenched. Trenched means it's like making a little channel, if you like, into the piece of timber all the way through to the depth of it. Maximum trench of the bottom plate is, if you remember, 3 mil. Correct. How do we know it was 3 mil? Because of this table, the standard table 6.1, pay trenches in place is 3 mil max. Okay. Bottom plate 3 mil max. It's not just the bottom plate, it's the same as for your top plate as well. So that was our bottom plate going up. The wall stud is going into the top plate. Zooming in. Notice that it is also trenched. Okay, trenching is not required, but it just sits that piece of timber so much better into where it needs to be. Now, I don't know whether you can pick it out. Can you see the truss roof right there in the triangle there? That's the part of the truss roof. There's one here, and then there's another, then there's another one at the end. There's one there. Skip. That's the other roof. You can see by the nail plate. So what's here? What's this bit? That will be for your ceiling joist. Remember how, although the piece of plasterboard that you've got on the ceiling is typically 1200 by say 2400, you need the mounting points as per the manufacturer's specification. So you do need the ceiling joist to be there to help you for that mounting point. So if that is the ceiling joist, you should then know where the hanging beam is. Okay, the hanging beam would be there. This is a binder as well. That's to help to stabilize the truss. You can tell just by using those connectors that they have. There's one there, and then on the other side, there's the other connector. So you either use a proprietary connectors like that to stabilize the ceiling joist with a hanging beam, or you can use a piece of timber piece. We either call that a timber clit or a soldier. So that's how you can recognize what it is. Okay, I'll leave you with that. The construction of intersection, we're going to have a look at that next. I'm just going through with showing you photos and linking it back to the standard to help you understand what we're looking at. So I would have said this already, but here are the intersection and the corners. Typically, the most common method of installing things are in the second option here for intersection. That's the most commonly used, and in the corners here. There's stipulation as to what's the minimum sizes, etc. So use those. So when you go out to site, have a look at what you've got there on site and compare that against the standard like I've just shown you. So this is a corner. That's your blocking, and it's between the two wall studs. I don't know how many of you have got your white card or have ever been to site yet. I would encourage you to go and get your white card, and when you do just drive by a site, you may be able to ask the site manager there to see whether you can go onto site. Do not ever go onto a site without getting permission. If you don't have permission, stay on the footpath. That will be your safest place to be. Be very sure of your surrounding. Keep a constant ears and eyes out for potential danger. Okay, take care of yourself. What I do is I just, on my travels, as I drive by, I go and stop. I have a look and say, oh, what's this? Just the best way to cement your learning is that you're going to site and look at what you've got there, check the book. Chances are is builders who are very good at cutting cost to make a profit probably find some way to make it a little bit cheaper as well. So learn, observe and learn. Anyway, going back to the text now. I don't know whether you can peg it amongst all these pieces of timber. You've got two windows here. You've got a window here, and you've got another window here. Okay, the construction is very similar. You still have, I'll just magnify this, it is a bit difficult to see. You still have your top plate, that doesn't ever change. Top plate has to go around all the walls. Right underneath the top plate is the lintel. Right underneath the lintel is your secondary jam stud, butted in with a jam stud, and they always come in pairs. Okay, that's your jack stud. As per the timber frame model, that's just doing the work of a stud, of a wall stud, only it is shorter. Then you've got this piece of timber, depending on what you want to call it. Either it is a head trimmer, a ledger, something similar to it. You know what the purpose is now for. It's a window, so you will have a window sill trimmer. And you know how to calculate the size of that too. So that will be your jack stud supporting the window sill trimmer and onto the bottom plate. Alright, look at the corners. Okay, look also what they're trying to do. I'm going to zoom out a bit and show you the load path. That's where the last panel of the wall of the ceiling trusses goes as vertical as possible from the top plate down to the stud, properly blocked in to your bottom plate, to your floor joist, your bearer, and to your stones. So that's one piece. The next wall is over here. It's putting concentration load here. That's not advisable, but it is what it is sometimes. The next one would be next one up. Okay, why am I going the next one up? How do I know? Well, you can see the roof truss there, and we already know this. The spacing for the ceiling joist, where you're going to mount the ceiling joist, is 600 centimeters. So that means this roof truss is going to support sheet roof. It's not going to be tiled. So it's 600, 600, 600, 600. That makes the distance between the roof truss to be 1200. Therefore, it has to be sheet roof cladding. So you're going following down again as vertical as possible to the ground, passing the load through. How you at what position you install the wall studs to support the truss, that kind of information will be given to you by the truss manufacturer, designer, etc. Okay, that's a point load. I'm not going to go into that now. This is the second story timber frame building that I spoke to you about. Two-story building. Nowadays, I want to make a comment though, that your timber frame buildings, by contemporary design, we seems to want more open plan living, so from a much greater sized room, and also we wanted double car garages. We can still use timber to span the 6 meters that we have for your double car garage, but it means that the timber beam here will be quite big, so we tend to replace that with steel. So there will be a combination of steel and timber in your timber frame design. Okay, this building is on a concrete slab. The bottom plate is at the edge of the slab, right there. The distance between this edge to this edge, this distance is called a rebate. This rebate, it is very much dependent on what kind of external cladding you're going to have on it. It could be AAC, aerated concrete, or it could be your brick veneer. So it'll be brick plus air gap. So it'll be 110 plus your 40, in which case your typical rebate for a brick veneer home is 150. Right, so you've got your bottom plate there. All I'm showing you is the construction of it and naming a few things that you would typically see on a building site. Obviously, TAFE does not endorse or disendorse any particular products, so I'm just showing you what it's likely to look like. So this is a window or fixed pane of glass, is a type of glazing, is a type of wall opening. This is how you can construct the corners, and is properly braced using metal straps. This here is a form of bracing. It's using plywood boards to do it. Moving up the window now, just showing you where the noggin is. It is continuous all the way through, and at a corner with proper blocking as well. Again, it is repeated, blocking your top plate. Remember, it has to run continuous as much as you can for all the walls. This is a wall opening, therefore it will have lintel. It will have jack stud to support it. It will be strapped down to secure it. What is this? I'm going to compare this with my standard. I'm just trying to get a sense of what that is. Before we do that, where is it located? It's located against this thin bit. That would be your platform floor, by the way, followed by your bottom plate and then your wall stud. So we've got your top plate here, then something, floor, bottom plate. So what's this something? Let's have a look. So here's figure 6.12 on wall stud. This is what you're familiar with. You've got your ridge beam, your rafter resting on your top plate. Underneath your top plate, you've got your wall stud to your bottom plate. Then you've got your floor joist, and underneath the floor joist you have bearers. Put this into a two-story building. Similar. Ridge beam, rafter, top plate, wall stud, bottom plate. I'm going to expand this now, make it a bit bigger. Bottom plate, floor joist, and then your top plate for the lower level. Okay, top plate, wall stud, bottom plate, floor joist. finished with para. So what's that bit in the middle then? That bit in the middle is called a floor truss. You can see by the nail plate, because that's a dead giveaway. There's definitely a truss of some sort. In this case, it is for the floor. Purpose is to hide surfaces. Our contemporary home nowadays uses a lot of aircon. Aircon size pipes are definitely much bigger than just the depth of the floor joist. So we have floor trusses. Typical height of a floor truss is about 400 to, so that's where all the surfaces are hidden. But remember how it just repeats itself, okay? Top plate, bottom plate. We'll talk about that platform floor in a bit. Just hold on for a moment. I know this is jumping ahead a little bit, but I think you probably should know about this. In the section 5, flooring and decking, it talks about different types of floor. Primarily, there are two types of floors. You've got platform floors or fitted floors. Your fitted floors are typically your floorboards. Okay, so you've got your hardwood floor, spotted gum, etc. Those would be your fitted floor. It is installed after the walls have been installed. Your platform floors are installed before the walls and the roofing is done. So that's where they belong to. So moving on now, onto the next picture. This is a front door, as you can see. It's braced. Don't know whether you can see this properly. I'm going to just magnify that. This is a surface pipe, soon to be enclosed in a brick column. Yeah, that's how you lay it out. Just to scroll up with that a little bit more, can you see the rows of noggins? The maximum distance is 150 as per the standard. Right here, figure 6.6 on noggin, maximum 150, and the distance between the top of the bottom plate to the bottom of your highest row of your noggin is 1350. So if you're going to work it out, the maximum height of a wall would be 1350 times 2, which would be 2700. And that's how we know your typical wall height is 2700. So you only have one row of noggins if you install it very neatly. Remember how I showed you the bracing wall, the bracing component? This is that bit. I'm just showing it to you now. I'll show you this again later on when we're doing bracing. On your bracing components, there's always information on it, and that's where it's all written. Okay, so just keep reading as to what it is. Structural bracing, how much you can brace for, something Newton, 3.4 kilonewton per meter, and it goes on. We're not going to that now. I'm just showing you what it is. So moving on a bit, what is this? This is a garage, isn't it? And this is temporary bracing. Very long piece of timber, making sure the wall is not going to fall over. You put a fixing there, and you probably put a fixing along the wall stub. You probably don't want to cut into the polished concrete floor. I don't think the owners would be very appreciative of that. Okay, you can see a combination of your steel and your timber being used in a timber frame building. That's okay. You can also see how the bracing is done in a line. Your load transfer is done in a line as much as you can, vertical line as much as you can. Oh, what happened here? Is this compliant? What is this supposed to be? Well, first of all, it looks as though it's still under construction, and that's okay. But Is it compliant as it stands right now? Let's have a look. So this is figure 6.9. It has 5 pictures on it. These 4 and the one over the page. And then there's rain beams as well. So what's this one? You've got your lintel here that is not touching the next stud. You've got something being supported, and you've got Nogginsy. Alright. Well, it's not that, because the lintel is not going to the next stud. So it's probably not that one either. Chances are it should be either this one or this one. I think what they were trying to do is to do this one, but it just wasn't done correctly, was it? Look at the lintel. It should have gone all the way to the next common stud. It didn't. Okay, have a look at it. And no, I didn't have a chance to go back and check whether they have fixed it. But as it stands now, if this was complete, I don't think that's right. This is how you're going to find out if something is right or wrong. Have a look at it, check your book, and go from there. And there's obviously something's missing here, but as I said, it's a construction site. It is not finished yet. This is your typical laundry window and door. The typical separation between those two is less than 100 mil. You will use a lintel across the whole lot. You won't separate it out, you just put it across the whole lot. And that will be your jack studs. So where did that 650 come from? It's here. Section 6 clause .6.3.6.6, third paragraph. Lintel trimmers shall be provided if the jack stud is exceeding 650 mil. Condition applies under this type of condition. Okay. So how does that apply practically? You've got a habitable space of 2400. Typical height of a door is 2 meters, 2100, let's say. 2400 minus 2100, so that would be 300. 300 is less than 650. Therefore, a lintel trimmer is not applicable in this case. So moving on now. You've already seen that. That's as a whole site goes. These bits are set downs. Set downs are typically happening in the garage or in any wet areas that you want to direct the water away from where you want it to be. You do not want your water to be in your living space. So the front porch, anything that's your toilets, bathroom, garages, whatever, set down to get the water out. And there's a whole set of wet areas right there. That also includes your laundry. Just another comment here. Notice that the bracing is done for the lower floor, including the boards. It is also applicable for the upper floor as well. Okay, just telling you where they are. I know we're not doing it just yet. Just telling you where they are. Keep your eyes out for them.